Set screw fittings are prohibited in wet locations. When installing electrical metallic tubing, also known as EMT conduit, around coolers, it's important to understand the regulations regarding the type of fittings you can use. Set screw fittings are generally not permitted in environments classified as wet locations. It's crucial to choose appropriate fittings that are rated for wet environments to ensure the safety and longevity of the electrical installation. Regarding clearance from the cooler surface, a minimum of 1/4 inch separation is necessary. Maintaining a clearance of at least 0.25 inches between the conduit and the cooler surface is essential to prevent potential damage from moisture or condensation. This separation helps to avoid direct contact that could lead to corrosion or other issues affecting the integrity of the electrical system. Now let's consider if a cooler is classified as a wet location. A cooler is generally not considered an indoor wet location according to the definition in Section 300.6 of the National Electrical Code, or NEC. Section 300.6 defines indoor wet locations as areas subject to saturation with water or other liquids, such as bathrooms, laundry areas, utility rooms, kitchens, and industrial work areas where water is used in the processing or storing of materials. A cooler typically does not experience saturation with water or other liquids to the extent that these locations do, therefore, it is not typically classified as a wet location. To summarize, firstly, set screw fittings should not be used in wet locations. Secondly, maintain a minimum clearance of 0.25 inches between the conduit and the cooler. And thirdly, coolers are generally not classified as wet locations per NEC Section 300.6. When working with electrical installations in environments where moisture is present, such as around coolers, it's important to choose appropriate materials and methods to ensure safety and compliance with electrical codes. Understanding the specific requirements for wet locations and maintaining proper clearances are critical aspects of these installations. For example, consider using compression fittings instead of set screw fittings. Compression fittings provide a more secure and watertight connection, making them suitable for damp or wet environments. Unlike set screw fittings, compression fittings are designed to create a seal that prevents moisture from entering the conduit system. In addition to using appropriate fittings, consider using corrosion-resistant conduit materials. Electrical metallic tubing is commonly used, but it is susceptible to corrosion in damp environment. Consider using rigid metal conduit, or RMC, which is more resistant to corrosion, or using electrical metallic tubing with a protective coating. Another option is to use PVC-coated conduit for enhanced protection against moisture. When installing the conduit, ensure that all connections are properly tightened and sealed. Loose connections can allow moisture to enter the system, leading to corrosion and potential electrical hazards. Use appropriate sealing compounds or tapes to create a watertight seal at all connections. Also, regularly inspect the conduit system for signs of corrosion or damage. Periodic inspections can help identify potential problems before they become serious. Address any issues promptly to prevent further damage and maintain the integrity of the electrical system. When running the conduit, avoid creating low spots where moisture can accumulate. Install the conduit with a slight slope to allow any condensation to drain away from the electrical components. This helps to prevent moisture buildup inside the conduit system. Be aware of the specific requirements of the local electrical codes. Local codes may have additional requirements or restrictions that you need to follow. Consult with a qualified electrician to ensure that your installation complies with all applicable regulations. When working with electrical systems, safety should always be your top priority. Always disconnect the power before working on any electrical components. Use appropriate safety equipment such as insulated gloves and eye protection. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Understanding the definition of a wet location is also important. The NEC defines a wet location as an area subject to saturation with water or other liquids. This can include areas exposed to direct sunlight and weather, as well as areas where water is frequently present, such as bathrooms and laundry rooms. While a cooler itself may not be considered a wet location, the surrounding environment might be. For example, if the cooler is located in a kitchen or food processing area where water is frequently used, the area around the cooler may be classified as a wet location. In these cases, you would need to use wiring methods and equipment suitable for wet locations. This includes using waterproof fittings, corrosion-resistant conduit, and ground fault circuit interrupter or GFCI protection for any receptacles. When determining whether an area is a wet location, consider the potential for exposure to moisture. If there is a reasonable likelihood that the electrical system will be exposed to water or other liquids, it should be treated as a wet location. This includes areas where condensation is likely to occur, such as inside coolers or freezers. In addition to the NEC, other standards and guidelines may apply to electrical installations in commercial kitchens and food processing facilities. These standards may address specific requirements for hygiene, sanitation, and safety. Consult with local authorities and industry experts to ensure that your installation meets all applicable requirements. When choosing electrical equipment for use in coolers and freezers, consider the temperature range. Some electrical components may not be suitable for use in extremely cold temperatures. Look for equipment that is specifically rated for use in cold environments. This will help to ensure that the equipment will function reliably and safely. Proper grounding is essential for all electrical installations, especially in damp environments. Ensure that the conduit system is properly grounded to protect against electrical shock hazards. Use appropriate grounding connectors and follow the grounding requirements of the NEC. Consider using a separate grounding conductor in addition to the conduit system. This can provide an extra layer of protection against electrical faults. Regularly test the grounding system to ensure that it is functioning properly. This can help to identify any potential problems before they become serious. Proper labeling is also important for electrical installations. Label all circuits and equipment clearly so that they can be easily identified. This can help to prevent confusion and accidents. Use durable labels that are resistant to moisture and chemicals. Place labels in a visible location where they can be easily read. In addition to the above considerations, it's important to be aware of any specific requirements or recommendations from the cooler manufacturer. The manufacturer's instructions may provide guidance on the proper installation of electrical systems in and around the cooler. Follow the manufacturer's instructions carefully to ensure that the cooler is installed safely and correctly. Finally, remember that electrical codes and standards are constantly evolving. Stay up to date on the latest changes and revisions to ensure that your installations are always in compliance. Consult with a qualified electrician or electrical inspector to stay informed about the latest requirements. By following these guidelines, you can ensure that your electrical installations around coolers are safe, reliable, and compliant with all applicable codes and standards. Remember that safety should always be your top priority when working with electricity.